Let's begin with something simple. Imagine pushing a shopping cart. You're applying a force, but can we actually measure how much? That's where Newton's second law comes in. It gives us a formula that connects force with two measurable quantities, mass and acceleration. It says that force is equal to mass multiplied by acceleration. In other words, force equals mass into acceleration. Now, the unit of force must be built from the units of these two, mass and acceleration. And depending on the measurement system we use, whether it's the SI system or the CGS system, the resulting unit of force changes. Let's explore how each system defines the unit of force. Suppose you apply a force on an object of mass 1 kg and it accelerates at the rate of 1 meter per second squared. In this case, the force you've applied is exactly 1 Newton. In the SI system, the unit of mass is kilogram and acceleration is measured in meters per second squared. So, 1 Newton is defined as the force which produces an acceleration of 1 meter per second squared in a mass of 1 kilogram. That means 1 Newton equals 1 kilogram multiplied by 1 meter per second squared. This unit, Newton, is large enough to be useful in everyday mechanics, from lifting a school bag to pushing a scooter. Let's now move to a smaller scale, the CGS system. Here, the unit of mass is the gram and acceleration is measured in centimeters per second squared. So, the corresponding unit of force is the dyne. 1 dyne is defined as the force that produces an acceleration of 1 centimeter per second squared in a mass of 1 gram. That means 1 dyne equals 1 gram multiplied by 1 centimeter per second squared. Because grams and centimeters are smaller units than kilograms and meters, the dyne is also a much smaller unit. It is ideal for measuring very small forces, such as in surface tension or molecular motion. Now let's compare these two units, the Newton and the dyne, and see how they relate. We know that 1 kilogram is equal to 1000 grams and 1 meter is equal to 100 centimeters. So if we multiply 1000 grams by 100 centimeters per second squared, we get 100,000 dynes. That means 1 Newton is equal to 100,000 dynes. Or in exponential terms, 1 Newton equals 10 raised to the power 5 dynes. So the Newton is a much larger unit. We use it for macroscopic systems like vehicles and machines, while the dyne is used for microscopic systems like cells and molecules. Let's solidify this concept with a quick example. Suppose you want to convert 2 newtons into dynes. We already know that 1 Newton is equal to 100,000 dynes. So 2 newtons would be equal to 2 multiplied by 100,000, which gives 2 lakh dynes. That is, 2 newtons equals 2 lakh dynes. This kind of conversion is very useful in physics, especially when switching between systems of measurement during experiments or data analysis. Let's recap what we've learned. Force is calculated using Newton's second law. Force equals mass into acceleration. In the SI system, the unit of force is the Newton, which equals 1 kilogram multiplied by 1 meter per second squared. In the CGS system, the unit of force is the dyne, which equals 1 gram multiplied by 1 centimeter per second squared. We also saw that 1 Newton is equal to 100,000 dynes. This knowledge helps us work with forces across different contexts, whether it's designing a car engine or measuring atomic level forces in a lab. I hope you now have a clear understanding of how force is measured in different systems and how to convert between newtons and dynes. See you in the next session with another exciting concept in physics.